All right. So first of all, I'm really glad that everybody has joined this workshop. And at Dockship, we feel very humble that Usha is with us today. So Usha, I'll begin with some quick introduction. So Usha is a Kaggle Grandmaster, if you don't already know, and she's the data science global ambassador for Z by HP and Nvidia. And she has a very strong foundations in economics, finance, business, and even psychology. Plus, she is a very great orator, and I guess today we are going to witness that. And a fun fact about Usha that she is an athlete also, and she has represented her state twice in national games. I don't know if people know about this, Usha. All right, and
Yeah,
she
yeah, thanks for bringing that out. Thank you.
sure, and she is also the organizer of TensorFlow user group in Mysore and GDG Mysore. And this doesn't stop here. Let me tell you, folks, Usha has some amazing credentials. So I'm just going to let you know about them. So first, she has credentials from University of Washington, from University of California, Berkeley, IBM Cognitive Class as well. We have Columbia University, and then she has credentials from Stanford University. She has done all those Coursera courses from Wharton School as well. From Harvard University, we have University of Edinburgh, we have John Hopkins University as well. The Wharton School, some other credentials she has, plus University of Michigan. First of all, Usha, I'm totally amazed, like how
Thank you
much.
so much for this screenplay. It's amazing. I think the way you put it on the screen is too good. Even I'm happy seeing all this for the first time. Thank you so
No,
much.
Usha, yeah, it's totally we are really humbled to have you here with all these credentials that that is on the screen right now. I hope the people who are joining in today will have a feast of knowledge that you will shower on them. And not to forget University of Pennsylvania as well. And if we talk about the work experience of Usha, so she is again participant at Stanford University, a beta tester at Coursera, plus a consultant at NeoIde, ambassador at AI Med, community member at NumFocus, plus again data science ambassador for Z by HP and data science global ambassador for Nvidia, and a data science consultant for infinite sum modeling.
Thank you so much, Saurav. I'm so happy, and it's my great pleasure to be at this event today. Thank you so much for
Absolutely.
inviting me once again.
And
Yeah.
let's not forget about the volunteering Usha is doing. So she is a co-organizer of Women in Machine Learning and Data Science Mysore chapter, TensorFlow group in Mysore, plus GDG Mysore that we mentioned earlier, and Mustang Research Group. And I had to trim few of her achievements from this presentation just to make it a bit shorter. But again, people who are joining in this workshop, you are here for a feast. And with that, let me just tell you the presentation format we have today. So Usha will be presenting for about 60 minutes for the machine learning workshop. And after that, we'll have a 15-minute Q&A with Usha. If you have any question, just drop your question in the chat section. And then later at the end of the workshop, Usha will be able to answer that. And again, the general rules of any Zoom conference, raise your hand if you have an urgent question or post it in the chat, and make sure to keep your mic mute. And of course, the phone should be on silent as well. So with that, Usha, I'm handing this to you, and I'm really looking forward to what you're going to teach us today.
Yeah, thank you so much, Saurabh. Yeah, and yeah, I'm so happy for the high turnout today. One thing which I have to say is we organized this Women in Data Science conference recently for Mysore. We used to have, there used to be like 12 to 13 speakers and all that. And we used to have only 12 people watching it, and 12, 13. So 55 is a huge number. There's somebody who's in the
Sure.
waiting room. I just admitted him. Yeah.
Yeah.
Hope if there is anybody in waiting room,
Mhm.
Hope I don't
I
let
got it.
anybody say. Yeah.
So,
So this is a huge number, and this is a great achievement for Dockship. So I'm a quite frequent person in conferences. So yesterday there was a conference for what is this Code Motion, which is a conference in Europe. One of the very I mean people. To I have not heard of the conference before, but they
yeah.
told me it's a very good conference in Europe and well reputed and all. And so I was taking a session on behalf of Pi Ladies Amsterdam,
All right.
and 13 people were watching actually. So this is really a great achievement and huge number. Dockship is going places, is what I can say from the
Oh,
metric.
thank you
Keep it
so
up.
much, Isha.
Yeah, yeah,
Yeah, it was amazing, right? So when we were talking about this workshop to all the people, and they were actually very excited about learning it from you, especially, and yeah, and really, I'm really looking forward to it.
yeah, yeah.
So
Thank you. Yeah, let's get started.
sure,
And
I'll
I'm
just
sure.
stop my screen for now, and I will
Yeah.
let you share your screen. Okay.
So today we're going to. I have given this presentation recently in Kaggle. This recently in DevFest, Vivek admit. Recently, do let me know if you find any option. Somebody is, waiting in the waiting room. I might tend
Yes.
to forget it.
No, we will manage
And
the
yeah.
admissions and everything.
Last Sunday it was featured. It was a pre-recorded talk, so this is a live one. And so this is about classifying melanoma in Lesion images. So you can also parallelly run this competition. Run This is a competition which got over.
Sure.
But Dockship, you will be having a lot of machine learning competitions, right? This is a vision based competition. Whatever knowledge we learn here, you can go and apply that to the competitions which is being hosted in Dockship. Let me check if there is any competition which is similar to this theme. So and you can apply this knowledge to any of the image based competitions. Is there any competition which is image based currently hosted in Dockship?
There are plenty of image-based challenges on Dockship, and I suppose that whatever you are teaching today will be very much useful there.
Yeah, yeah. So I'll also before going, I'll point out. So see the butterfly classification AI challenge, this one, where you have to classify the given images into 50 categories. It's a multi-class classification problem. This one you can apply this. So, and it is also having prize money as well. So try this competition, and where else can you apply? Um, Cocolite object detection AI challenge. Okay.
It's an object detection, yeah.
Yeah, this one Caltech image classification challenge you can apply here. And there are a lot of so this one fashion MNS you can apply. This one CINC image classification also you can apply. See, object detection, it's slightly different. You just have to change the architecture, but everything else will be same. The architecture we are using efficient net. Instead of efficient net, you can use efficient net, which is for object detection. That's all. You'll just be changing 3 lines of code. This will be a baseline architecture we are dealing with. So you can apply whatever knowledge we are doing to almost some 10. From whatever I see, you can apply it to something around 10 to 15 10 competitions at least here. So you can execute the code alongside me, but one thing is there is uh, yeah, I'll share the notebook link. Did I share the notebook link in the chat? Yeah. So this is the competition. So you can go here, and you will, for me it will be edit, for you it will be like copy and edit. Some option will be there which is for forking the notebook. So click on the fork. So once you fork the notebook, you will be able to start running it alongside me.
Sure.
So
I think Yusha, you can begin with your notebook, and I guess people will be following it. Uh,
yeah.
yeah.
So this is a competition which is organized by two organizations. One is CSIIM, Society for Imaging, Informatics and Medicine. And there is another organization called ISIC, which is International Skin Imaging Collaboration. So these two organizations have come together and they've organized this competition. So the main intention for them is like, see if you take ISIC, this is an international organization which has got the largest archive, image archive in the entire world. And so this image archive is like, publicly available free image archive. So their main intention is to, promote a lot of innovation and digital techniques, and to reduce the mortality of melanoma. So if you take melanoma is one type of skin cancer, and if it is not treated early, there is mortality. There's a high probability of mortality. So if you take, a lot of people, a human being might have moles and scars, I mean, in a lot of places in the body. So any one or two of the moles might have, melanoma. So is it possible for a dermatologist to sit and, analyze each and every mole in the body? It's a time consuming task as well, and there are possibilities for human errors as well, or negligence as well. And the person themselves might not have noticed there's some of the lesion, might have melanoma. The person himself might not have noticed. So there's a high probability of negligence and errors, and if that happens, then there's high rate of mortality going to happen. There's almost American Cancer Society, I think in America alone, they've estimated around 100,000 deaths. 100,000 people will be diagnosed by melanoma by 2020, and there'll be around 7,000 deaths in America alone. And then imagine the other countries which is still not having that good medical infrastructures and facilities. So it's good to have an AI based diagnostic systems which can help in accurate diagnostics, at the same time early diagnostic as well. So
Sure.
that is why they've come up with this competition. So this is the
Usha, we have one
background of
question in the chat that, do we need to enable TPU hardware acceleration in the notebook by Ayush?
Yes, you will have to handle the add the enable the TPU acceleration. Where you'll have to make it TPU V38. One more thing you'll have to notice is Kaggle gives a 30-hour limit on TPUs. Okay, so if you you'll have to be very careful on your TPU limitations. Once you finish this notebook, you'll have to go and ensure you have closed your TPUs, and you'll have to go to your notebook section and check out if you've closed your TPU thing. Otherwise, the 30 hours will get exhausted. For a week, you get only 30 hours. So please be mindful of that. Otherwise, you'll have to go and purchase some from Google Cloud GCP, and all it's going to cost you. And if you have that $300 free credit, then the free 100, see, even I got like a lot of offers, a lot of people give me that subscription of $500. Many price competitions, they'll give me Google credit, $500 and all. But what happens is, see, this is based on the availability. So even if I have like $1,500 of cloud credit, the mission should be available at that point of time when you're running a competition. So these are like limited resources, use it, with thought. So this is about the competition. Enable your TPU, and so everything else, I think internet you can keep it on. So this is about the organizations which is organizing, a little background on who's organizing and why they are organizing it. And the problem statement is this: there are huge images, and so this, if on my left hand side I've got images which has melanoma, on my right hand side I've got images without melanoma. So this is not a very detailed notebook which is covering all aspects of the competition, because this was prepared for DevFest, and for that they gave us only 45 minutes. So that 45 minutes I cannot cover everything. So there are a lot of aspects we are not covering in this notebook. but I'm just giving you a little heads up. So the basic problem, whatever we are covering in the notebook, is given an image, you have to classify whether that particular image has got melanoma or not. So left hand side, I've got images with melanoma. On right hand side, I've not got images without melanoma. I have to do this classification. Now let's head over and see, examine the data set a little bit. So let's examine the data set a little bit, what kind of data set we've got. If you go to data, so you've got both test data and you've got train data, and you've got you've test and train is the metadata. That is the, you've got some metadata, like I'll just click on train CSV. You've got the image name, patient ID, the gender of the person, age of the person, additional details you've got. So you've got a lot of features like this. And in addition to the metadata, you've also got the image data. So the image data is available in the form of JPEG files, and it's also available in the form of TF records. So you should understand what is TF record format. These days, most of the data sets are in the form of TF records only. So you should also have an understanding. The reason why I'm coming to this page and showing the data set is because you should understand the data format. So this is a very small presentation, 1 hour workshop. So I can see you can combine the both text data and your image data and build a model to make prediction. That is the best model. That is why they have given you both image and text data. You will have to combine both. But here we are going to use only TF records, not even JPEG. We are going to use only one form of data, which is TF records. But it's not going to be that difficult to combine text and image data. You can do it with few lines of code later. So let's first see what is TF records and what is TPU. Let's understand a little bit more. So this piece of code, so the way you run it in Kaggle is, you cannot run the text cells. You can run the code cells by, there's a play button. So you can click on the play button and it will start running. So it's similar to Colab. I think any data science enthusiast would have used Colab. So it's similar to Colab. So you can just click on the play button and start executing it. And these are the so if you get cancelled run here, it means it's still running. So if you want to like run all the cells, you can go to run and click on run all, but don't do that, because when you do run all, there is this place particularly where your model is running. It will take around 12 to 30. I have put only one epoch. For one epoch itself, it is in TPUs itself, it's taking 12 to 13 minutes. So it can take a longer time. So let's execute cell by cell. So this is just installing the external libraries and then importing the main packages like NumPy Pandas, TensorFlow, STF alias, EfficientNet alias, and all that. So I'm also using Kaggle dataset. This is one Kaggle API for doing certain things. Here in this competition, if you see, TPU is a product from Google Cloud. So you will be able to get TPUs only from Google. You won't be able to get TPUs from any other vendor. TPU is a homegrown product of Google. Internally, they have been using internally. I mean, almost all the products of, if you take TPU, so there is TPU V2 also, there is TPU V38 also. But TPU V38 is much faster than TPU V2 version. So Kaggle comes by default with this TPU V38. So you're all using this TPU V38. So you can go to TensorFlow documentation. You will get this, specification for V2 and V3s. And so most of the Google products are powered by TPUs. And what are TPUs is, these are like custom specific circuits, which have a specific purpose. The purpose way they are built is like, see, most of their products they've been using it internally since only for the last few years it's been released to the market. But before that, they've been using it to power all their internal products. So like Gmail, Google Drive, all your Google products like Google Docs, and all this is powered by TPUs only. And so this is very fast, this is super fast, and this is fast for only certain kind of operations. So what kind of operations it is fast is, it is fast for multiplications. See, if you, when you're building neural networks and all that, this involves like enormous amount of multiplications and enormous amount of additions you perform, right? So it is very fast for these kind of operations. TPUs are extremely fast. And so if you take see, when I say fast, I can't just say fast, right? I need to prove some metric. So the way I prove that metric is, see, this is like a metric where they've compared ResNet 50 is one of the deep learning architecture. So when you compare ResNet 50 to train ResNet 50 from the scratch, so if you're going to use V100 GPU, all I mean GPU is not a product of Google. GPU, I think there are a lot of vendors who give you GPUs, right? So for GPU, there is one K80 GPUs, is there. Kaggle offers K80 GPUs. V100 GPU, you can get a V100 is much better version of GPU. So in V100 GPU, if you train ResNet 50 from the scratch, it takes you around 216 minutes. But in TPU, it is 27 times faster and 38% lower cost as well. And so how this whatever takes 216 minutes in GPU takes only 7.9 minutes in for 90 epochs. So 216 versus 7.9, I will let's have it as 8 minutes. So 216 minutes versus 8 minutes. That's how you can tell that's how fast TPUs are. So TPUs are much faster than GPUs. GPUs themselves are used for parallel computations and for when you have enormous amount of multiplications and additions. TPUs themselves are somebody is drawing a line. Okay, TPUs themselves are faster, and but GPUs themselves are faster, but TPUs are much faster than GPUs. So if you have a GCP credit, then you can get TPUs. And yeah, outside this, so for this experiment, we are going to use TPUs. And so yes, to be able to understand, there's some red line coming up everywhere there. All right. To be able to understand this thing, what I say, so if I'm going to use TPUs, to understand TPUs, like to see, you can also use TPUs in Google Colab. See, Kaggle offers only like 30 hours, so that may not be like working out for everybody. Like mostly people use Colab only. So Colab, everyone gets free GPUs and TPUs, and that's like you get like unlimited GPUs and TPUs. So most of you, for your competitions in Dockships, you can use Google Colab, something which I would recommend. And you can also use Colab Pro, which is like $10 per month. And $10 per month is like you'll be spending something around 750 rupees. But it's very good. See, you can go to runtime and you can change the change runtime type, and you can change none CPU, GPUs is there. So for all your competitions, in Dockship, you can come to Google Colab and you can use this unlimited TPUs. And so when you go for Colab Pro, you will be given more preference, and your RAM will be more, and you will get a better. I think you will get a better TPU. I think TPUs itself, like there are many versions. So TPUs and GPUs, there are many types of GPUs. You will get the fastest one, and you will get high preference as well. So I would recommend, if you are a very hardcore competitors and all that, go for Colab Pro. Or if your money is not a constraint, set up your own GPU machine at home is what I would buy, and invest some time and set it up. Rather than going for cloud, if you're fine with it, then it's okay. But setting up your own thing is best. And the next thing is,
Hmm. This is what is
so
happening.
yeah, so this is with regards to your competition. So see, setting up your environment is very very critical. So if you're participating in competitions and if you don't have the right kind of environment, see, nobody has times to run models for 5 days or 4 days to 6 days. And so setting up the right environment is the most important thing. The person with the best configuration is the most in most of the competitions, who's got the best system setup, has higher probability of winning the competition as well, provided he puts in some effort to learn everything properly. So this one is about TPU. So when you are using TPU, whether you're using it in Colab or Colab Pro, whatever it is, so you need to understand a little bit concept. Like, it's not enough if you go to Colab and change the runtime as TPU. That's not enough. Your TPU will not be enabled. So you'll have to type in this one paragraph. What is this one paragraph? I'm going to teach you now. So this one paragraph, first thing is TPU will be running on cloud workers. So there will be a lot of remote workers. First, you should identify one of the workers and you should connect to the worker, and then you should initialize. So identifying the remote cluster, and you have to connect which cluster is free. You have to connect to the cluster, and then you have to initialize the cluster. So this job of identifying, there is some class called TPU cluster resolver, which will do that job for you. This, you will have to create a TPU cluster resolver object. Once you create this object, you can go and use this method. There is a method like tf.config.experimental connect to cluster. You can pass this object, which will go and look for the free clusters, and it will connect to one of the free clusters. And after it gets connected, you will have to initialize, use the method initialize TPU system and initialize your environment. So this is a step. Identify the free cluster, connect, initialize the system. Done. So then we're using a lot of TensorFlow concepts here. So you need to understand, see, there are a lot of PyTorch lovers, I know. But TensorFlow is also becoming, I mean, a lot of the reason why people don't like TensorFlow is, I think when it got released, few years back, it was very hard. Now when I look at TensorFlow version 1, I cannot touch TensorFlow version 1. I hate TensorFlow version 1, but TensorFlow 2 is like similar to Keras in most of its coding syntax and all, so it's much simpler. And I'll be taking you through TPU because I cannot cover everything here. There are few things where I'll be pointing you out to the documentation, which you can go and learn it later. So I'm going to walk you through something called tf.distribute. What is tf.distribute is? Tf.distribute is a high level API in tf.distribute is a high level API in okay. Why is tf.distribute not coming?
We have one more question. So Ayush is asking like, should data and model both be loaded to the TPU/GPU, or can we just load one of them?
See, you don't have to do anything. All you have to do is fork my notebook and start running. You don't have to touch anything. Fork the notebook, start running the cells. You don't have to download any data. You don't have to load any data, nothing. That's the reason why I'm giving workshop in this particular setting. The reason why I didn't choose Colab is, because you're working, you'll be doing a lot of workshops and a lot of competitions in Dockship. So ideally, I should give you a workshop in Colab. The reason why I didn't do it in Colab is, if you see the input data size, it's 108 GB. So it is almost 110 GB. So downloading 110 GB, and then not many people will have the good broadband and all that. First of downloading 110 GB to your desktop, and then uploading that 110 GB back to Colab will take some 2 hours for everyone. So it is, see, in a short workshop like 1 hour workshop, I think that's going to be very difficult for us. So that's why I'm giving the workshop in Kaggle. Otherwise, I would have given the workshop in Colab, because the input data size is huge, 110. So for this particular workshop, all you have to do is, when you open up, the link of the notebook is in the, for the people who have joined new, paste the link of the notebook. I'm just pasting the link of the notebook again. don't ever try to download the data set and uploading it to Colab itself will take you. Most of you might have normal Colab and not the Colab Pro version, so uploading will take another 2 hours. And then by the time some disturbance occurs, then everything will be lost again. You'll have to start all over again. That's like going to get clumsy. So don't try all that. What you have to do is click that notebook link. I've repasted the notebook link in the chat window. Click that, and after you click that, you will have a blue color option called copy and edit. Click on that copy and edit, and then start running the cells. That's it. You don't try to run the comment cells. The code cells, see, these are the code cells. When you click on the code cell, you will have this run option. Run that. So I'm going to,
Perfect.
I ran this cell, right? This one I run. So when I run it, it will be coming cancel run. It means it's still running. Once it is completed run, it will be like that cancel run. Now it is completed running. Now I'm going to run another cell, which is the TPU initialization and all that I'm going to run. So now it's still running. So this is how you run cells here. So now there's one important concept which you need to understand, tf.distribute. What is tf.distribute? Tf.distribute is a high-level API in TensorFlow 2.3. So now you are having, for the sake of intuition, I am explaining it in a very simpler terms. So for example, you have some 10 jobs. So now you have some 3 TPUs. So you don't have to sit and manually, okay, the job 4 and 5 will go to the first TPU, job 2 and 3 will go to the thing, GPU. You don't have to sit and manually do all these things. There's a high level API from TensorFlow called tf.distribute, which will take care of all that jobs for you. That parallel processing, the reason why we go for TPUs and GPUs is because of their ability to do parallel processing. So all that parallel processing, how to distribute jobs, how to get jobs done parallelly, and all that will be taken care of by this high level API of TensorFlow, which is tf.distribute. See, PyTorch might have something similar to this, but I'm not aware of it. So see, PyTorch is much more commonly used and more famous framework. I mean, everyone in data science loves PyTorch because when it got released, the initial version was very. Okay, there are a lot of people continuously joining. I think the late joinees, I'm not sure they might. Is this session recorded? The late joinees might miss out
Yes.
on a lot of things.
Yes,
Uh,
yes. We are recording this session. You can continue with your pace, Usha, and then we will give them the recording.
Yeah. So the TF.distribute, this API will take care of all these things. So it's more important that you should create the strategy object. You should create the TPU strategy object. So in TF.distribute, see, if I'm using TPUs, then I have something called TPU strategy. There are multiple strategies I have, like multi-worker strategy, mirrored strategy. There are multiple strategies. For GPUs, you can use those strategy. GPUs will make use of those functions to do the parallel processing or distributed processing. For TPUs, there's only one strategy called TPU strategy. So I need to create an object of this TPU strategy, and this TPU strategy is present inside this tf.distribute high level API. And I'm creating this object. Once I create this object, under this object, I will be putting all the codes which is involving higher level of multiplications and higher level of additions. All this code will be coming under this strategy scope. So before you do your modeling, there will be a lot of pre-processing and things which are being done. You won't be doing those pre-processing and all that in under your strategy.scope. Only your modeling part, you'll be doing it under strategy.scope. And so this is about creating the strategy. This is about TPUs. And one more thing is, if you're using TPUs in Kaggle, there's a certain procedure. But if you're using TPUs in Colab, you can go check the documentation where, for Colab, I think you don't have to do anything because it's all set up already. So if you read the tutorials, you'll be able to understand better. And but if you're using it in Kaggle, you will have to ensure your data should be present in Google Cloud Storage only, and you should use some of the Kaggle APIs to actually read and do some pre-processing. So your data TPUs can read your data only from Google Cloud Storage. So I think for Colab it is automatically handled, I think. But for if you're executing this in Kaggle, then you need you need to call the KPI, Kaggle API, which will accomplish this task for you. So the takeaway here is TPUs can read data only from GCS, Google Cloud Storage. And the Kaggle API, which will do the job for you, is Kaggle datasets dot get GCS path, and you just have to give the name of the data set, and it will go and upload it in the GCS bucket automatically for you. And so one more thing, which the top search result. Okay, 1 minute. So one more thing which you need to understand is about TF records. So the data set I showed you is TF records, right? So it is in the form of TF records. What is this TF records? So TF records is nothing but TensorFlow's own binary storage format. They have their homegrown binary storage format. You can convert any of the data type into TF format. There are methods to convert JSON to TF format. There are methods to convert string, sequence of text into the TF records. TF records, if you take if you use most of the TensorFlow's pipelines, input pipelines, pre-processing pipelines, and all that, when you use that, I mean, if your end-to-end code execution is going to be in TensorFlow, then it's highly recommended that you use TF record. Or if your data is not in TF record, then it's better you convert it into TF record. Because this TensorFlow's APIs will give you better performance when you use TF record as your data format. For us in this competition, it's already available in TF records format. And so this is about what is TF records. And the next thing is, this is your data set. You don't have to do anything downloading data. I'm just repeating again, you don't have to do any downloading data, uploading data, nothing. The notebook link which is given, you'll have a blue color option for you. The blue color option, this will be visible, copy and edit, click on that and start running the notebooks. So did I run this code? This code I think I ran. So I'm going to run this code. For running the code, click on the code cell, run, click run. So it's running. And so this data, you have, you have the, test data, and you have the metadata, you have TF record, JPEG, and all that. We are using only TF record. That is, we are using only image record. But the best for this problem, if you want the best solution, you should combine both the image data and the text data. But this is a very short session, so we cannot do an elaborate walkthrough of the code, but you can try it out. There should always be something which you should try it out on your own. So after this workshop, you can go and try out these things. So under TF records, if you see, you have already test and train TF records. So we're going to just create, add from the trained record sets, we're going to create one more bucket for the validation data set. So this piece of code is about creating, 3 buckets, like training set, test and training is already there. From the training set, I'm already creating an extra bucket called, I'm setting aside some piece of some certain amount of records as a validation set. So this piece of code is doing that. So I have 44% remaining in my system, which is 57 minutes is what it's showing. And let me cover the important points before I get turned off. And so I've executed this code, yes. And TF data. So TF data is again a TensorFlow API. So there are a lot of TensorFlow. TensorFlow comes in with this neat, handy APIs, which makes a lot of things very, very simpler for you. And I'm sure PyTorch has got something amazing as well. So now TF data, this is another again pre-processing, high-level pre-processing input pipelines. See, before you go to your modeling, you have that pre-processing pipelines. So in order to make that pre-processing pipeline easier, TensorFlow has come up with something called TF data. So what is some of the advantages of TF data? If you see if you're not using anything TF data, if you're doing sequential operations like this, you will first do an input output thing. You will wait till that input output is coming. Then you will do a transformation. Then you will go and fetch the next data. and then you will do, I mean, then you will do some transformation, you will wait till. So if, when you do sequential executions, input output like this, there's a lot of idle time out there. The idle time is increasing. Instead, if you use TF data pipeline, you can cut down on the idle time. So that's some of the advantages of tf.data. And so what is coming up next is, so I'm going to use this TensorFlow's tf.data API. So you can go to this TensorFlow's tf.data API, and you can just check out all this things. If you want to learn more, then you can go and take out the tutorials and how to optimize performance, analyze performances, the elaborate tutorials here. But here in this notebook, I'm just going to keep it short and cover the basics. See, what I'll do is, first I'll create a tf.data object, and then once I create that object, with just some method call, I can do a lot of transformations. I can do a lot of transformation very easily with just a simple method call. So coming up next is creation of tf data object, and then tf data object, and then applying transformations on the tf data object. So what are these transformations and why do we do it, and all is coming up next. So in order for you to understand this whole thing very easily, you have something called load data set. There are a lot of utility functions which is coming up. So in order for you to understand this utility function, which function is calling which and what is that function doing, I just created this block diagram. So this will help you understand which function does what and which function calls what. So there are three utility functions for training data, validation data, and test data respectively. There are three utility function, which is get training data, get training data set, and get validation data set, get test data set. There are three utility functions for the three buckets which we created earlier. And those three are these utility functions. These utility functions, all the three utility functions will call something called load data set. This is an utility function, and this load data set in turn will call one method. See, since our input data is in the form of TF records, in order to create a TF data object, it will call an abstraction called TF record data set. This is an abstraction which is available. So if I have data in the form of TF record, then I can use this abstraction to convert it into a TF data object. So if I have data which is not in the TF mode, there are multiple abstractions available. So the first job in load data set is to create TF data object. And then, I'm also calling another utility function, which is TF record. And I have train, validation, and test utility functions. So the first job, where what I'm going to do is, I'm going to call a load data set utility function. And after I call this load data set utility functions, and applying several transformations here. So the first transformation in train is something called augmentation. And after augmentation, I'm applying multiple transformations, which is repeat, shuffle, batch, and prefetch. But in validation, I'm performing only three transformations, which is batch, catchy, prefetch. And in load, I'm performing two transformations, which is batch and prefetch. So what are these transformations? We'll be coming back. So till now, what is we understood is, what is TF data? TF data is the input processing pipeline of TensorFlow API. The reason why we go this is, if you do sequential execution, your idle time will increase. In order to cut down on your idle time, you're going for TF data input pipeline. So this will cut down on your idle time, which means you can do things faster. The second point is, see, if you want to use this API, then in order to use this API, I have written a lot of utility functions to make it easier. So this is an explanation for, there are, I think, some 10 utility functions. Which function calls which, and how the function call goes. In order to make it easier for you to understand, I drew this block diagram. So there are three utility functions for each of the three buckets. And in each of the utility functions, you have a load data set and a bunch of transformations happening. Transformations are given in orange color, and loading the data set is given in rose color. And then, so this is what is this. So I'll just go ahead and tell you like what each of the utility function does now. So this utility function here, oh, this is executed. I'm just running this code. This converts an image into a tensor, and here TF record will call the subtraction, which is uh, TF record will be, giving, I mean, it will take an data and it will give the data in a certain format. This is a utility function. So this load data set will be calling this abstraction, which is TF record data set, and it will call this TF record method, read TF record method. So I'll run this as well. So which method is calling which will be clear from this block diagram. So, I mean, if it's little overwhelming for you and if you're a beginner, all you have to understand is you are setting up an input pipeline right now. If you're a beginner, don't feel overwhelmed. Just understand you're setting up an input pipeline, and to set up an input pipeline, TensorFlow has got a lot of APIs. So if you don't understand the APIs, you can go to the documentation, check out like how the what's the syntax and what's the input parameters, output parameters, and all that, and you can start executing it. And so here there is one more thing called data augmentation. So data augmentation means, see, my data, this is an imbalanced data. So if you take the ones without melanoma and with melanoma, it's imbalanced. One class, there are two classes. This is a binary classification. You are classifying whether an image contains melanoma or does not contain melanoma. It's an imbalanced data place. We have lot of data for one class. That is lot of data for a lot of images have melanoma, and without melanoma, the data is less. This is an imbalanced data set. So there is a common pattern how to handle the imbalanced data sets. Whenever you have an imbalanced data sets, what you do is there is a technique called data augmentation being used. The advantage of data augmentation is when you have an imbalanced data, you can increase the data set by performing certain set of operations. This technique is called data augmentation. Data augmentation means when you have a highly imbalanced data, and here in this particular use case, we have an highly imbalanced data. So in order to increase the data set, what we do is we perform this operation called data augmentation. So without going out and finding extra data, we just use this operations to increase the data. And so for doing data augmentation, also you have something from TensorFlow. There are two APIs. One is Keras pre-processing layers. The other one is tf.image. So out of these three layers, you can either go for either of the one, but tf.image is preferred if you want much better fine tuning. So I'm using tf.image. I'm doing only one particular augmentation. That is, you take an input data and then you apply some transformation, you will get multiple. So if I take this input data and if I just do a detexturize, I'm getting a new image. So I can, enhance the edge and I can create multiple data from a single image. From this single image, I created around 6 images by applying multiple transformations. So this will augmentation is a technique where you can apply some transformations and create more data without having to go out and collect new data. So this is a technique which comes in handy if your data set is highly imbalanced. So this is about data augmentation. And so I've run all this code, I think. So I'll come, and so data augmentation, there are so many augmentations. There are 10 to 15 transformations you can do. But here I'm just keeping it. This is a very baseline notebook. I'm doing only one transformation, but to go home and try out the other transformations. So as I already told you, these are the three utility functions. When these three utility functions, what is happening is given in the block diagram. So the ones in the orange are the transformations, and the ones in the rose color is just in utility function. So what are these transformation? What is augmentation? I just told you. That is, if you have a highly imbalanced data set, then you do this process called augmentation. What are these other transformation? What is repeat? What is shuffle, batch, prefetch, and all that? See, now this what we are doing currently is we are building an input pipeline. So what is prefetch is nothing but prefetch means, see, now I'm executing one process before another process. While I'm executing the first process itself, there will be another worker thread which will go, and for the next process, it will parallelly, while I'm executing the first process, there will be another worker thread which will go and fetch the data for the next execution. So you will be cutting down on the idle time, that is executing first process. Then after completion of first process, you will go and fetch the data and come. Then there'll be a lot of time which is getting wasted. So in order to avoid this, there is a transformation which is available for us called prefetch, which will do this job. While there's one thread which is executing, doing the first process itself, parallelly you can go and fetch the data for the next execution. And what is shuffle is as much you require data to be randomized manually. You don't have to write any utility function to randomize your data. There is a transformation called shuffle. If you just call dot shuffle method, that will do that process for you. You don't have to sit and write utility function to do shuffling. You don't have to do your sit and write utility function to do prefetching. This dot prefetch, there's a method available. You just call that method, that will handle the job for you. And the same thing is map. Now we are using TF records. Now for example, you have some 10,000 TF records. For every TF element in the TF data object, you want to apply a certain function. That function can be anything. Maybe you want to just print out a name or whatever function, but you want to apply to every element in the TF data object. To do this, you have a transformation called map. If you just call the map transformation, automatically whatever function you want will be applied to every element in the TF data object. So these are some transformations. What are transformations is it will make your job easier. You have a lot of utility functions which is coming up with TF data input pipeline, which will make your job easier. So these are the transformation functions. And so this is what happening. So if you come down, so if you'll see, I'm not sitting and writing the logic to randomize shuffle. I'm just calling dot shuffle method that will randomize. Prefetch, I'm just calling this one line and the one word, and that will automatically do the job for me. So start running all your utility functions. This is a bunch of utility function to find out how many images are there in the training data set and how many images are in the validation data set. All right. We are using a learning rate called cyclic learning rate. This is a bit advanced and intermediate level session which requires the knowledge of deep learning. So for somebody who's a beginner, this session might be little overwhelming is what I feel. If you feel it's very overwhelming, I can give a beginner level session on a different day. But this session is for somebody who already has a knowledge on deep learning and who already at least has a basic knowledge of deep learning and has participated in one or two competitions in Dockship. And you just want to understand the extra things like TF distribute APIs, how things can be done very quickly in this and all. So I would say I would call it an intermediate level session. And if you are a beginner and you're starting out, don't feel bad or let out. For everyone to come to an intermediate level, it took a lot of time. So on the first day, nobody learned anything. So don't feel overwhelmed, or don't feel like it's going above your head and all. So cyclic learning rate. So cyclic learning rate is a particular learning rate. So more about, I'll just skip the cyclic learning rate owing to my. So there are several learning rates available. So the reason why you choose cyclic learning rate is you will get an fairer of better understanding of how you're, whether you're choosing the right optimal learning rate for your particular use case or not. So you'll get a better understanding of it. For that purpose, I'm using this particular learning rate called cyclic learning rate. I've given a notebook credit. So you can go and check out this notebook, which is a one full notebook explaining what learning rate is all about and what is cyclic learning rate and all that. And so this is an utility function which does this job for us, which calculates the cyclic learning rate. And finally, we have come to the modeling part. So modeling part, this is an image classification problem. One of the deep learning architectures which does the image classification is efficient net. So we are going to see there are seven. Almost anybody who has done deep learning before might have understanding of convolutional neural networks and all that. But how is efficient net different from other convolutional neural networks out there? So the way efficient net is different is when you're scaling up. See, if you're doing this is efficient net architecture. So if you will first develop a baseline architecture. In ResNet, you have got different architectures like ResNet 50, ResNet 32, and all. First, you will build a baseline, and then you will increase the number of layers to get a better accuracy and stuff. So when you increase, in what when you increase, what should you increase? Should you increase the width or length or resolution? What aspect should you increase? So most of the previous architectures have concentrated on one of the, either they, when they wanted to scale up, they scaled up one of the features like either width or height or the resolution. They, focused on one of the parts. But in efficient net, we scale across all three things: width, height, and the resolution. And to scale up across all three things uniformly, we use something called compound scaling. And so I will not get detail into what is efficient net, what's happening, but what you need to take away from this is how it differs from the other architecture. In USA, other convolutional neural architectures, they focus on either scaling up against width or depth or the resolution. Here you are scaling up across all three dimensions, both with the resolution and deeper depth. All three resolutions you're trying to scale up. To scale up, you're using a special kind of scaling technique called compound scaling. That's it, you need to understand in this. And one more thing is, for every architecture, you need a baseline. For ResNet, you have a baseline. From the baseline, you are increasing the number of layers and creating different variants. So the same way, to create a baseline, they've used a special kind of technique called neural architecture search. Using this special kind of technique, they came up with a baseline. After coming up with a baseline, they use this compound scaling architecture to create various variants. So efficient net, you have got efficient net 0 to efficient net 7. So B0 to B7, you've got 7 variants. The seventh one is giving you more accuracy or is better or super fast. So they have tested out the performance of efficient at B7 with the other convolutional neural architecture. From the diagram, it is very clear that efficient at B7 is super fast. The red one is the efficient at B7. So you can try out more for a competition if you're working in competitions like Melanoma, also whatever in Dockship, if you're trying out different competitions. And then you can do an ensembling of various architectures. You can do an ensembling of various architectures instead of going for one architecture. And so this is strategy.scope. So from here, I'll start executing in TPUs. So I've executed all the code above me, I think. So I'm just rushing up because my battery will dry
Uh,
out. That's why I'm going super fast.
no, you are
And
with the correct pace. That's all right.
yeah, yeah. So from this part on, everything will get executed in TPU because I'm giving a with strategy dot scope, which means from this on, I'm going to have from this point on in my notebook, I'm going to have computations with higher multiplications, lot of multiplications and lot of additions are going to come up. So I'm going to enable my TPU. To enable my TPU, I created a strategy object in the beginning. I'm creating initializing strategy.scope. From here on, all the code down underneath it, execute it, and TPUs. So this is where I construct my model. This I'm using transfer learning technique where the first layer is my efficient already pre-trained model, efficient net B6, and then I'm adding 4 5 layers above it, the average pooling layer, dense layer, dropout, dense, and all that. The final layer dense has got only one node because this is a binary classification problem where you're classifying it as either the image has got melanoma or the image does not have a melanoma. And the basic metrics, like you're setting up what is the optimizer. You can choose any optimizer, the one which works better for your use case. Here I'm using an Adam optimizer. The loss function is it's a binary classification problem. So I'm using a binary gross entropy metric. I'm going for accuracy. This I'm just building a basic model. This session is an intermediate level session. So I assume like the right audience for this session is and somebody who already knows of all these concepts, like who already has the basic knowledge of deep learning, who already understands convolutional neural networks, and who has participated in 3 to 4 image competitions and Dockships, and who already understands these concepts like optimizer, loss, and metric. This is an intermediate level session. If there are a lot of people who feel it's overwhelming, then I can take a beginner level session on a different day, or
That
I
would be
take
wonderful.
yeah
That would be
I
wonderful.
take yeah so that would be so don't the reason why I'm stressing this out is
Mhm.
there might be some beginners out here who shouldn't feel overwhelmed and give up on their learning curve. So that's why
Sure.
I'm just so if you're a beginner, don't worry at all. It's completely fine. Everyone to come to the intermediate level, they would have worked hard throughout over a period of time to reach to an intermediate level. So don't feel overwhelmed.
I
And
think
so this
it's a good start. People should know that there are higher things in machine learning, and I think this is a good workshop for them as well.
yeah so this is the part where I create my model, and I'm just running my strategy.scope. And when I come here, I'm running my model.fit method, where I'll be calling my here is where the exact pattern matching and all that happens. So I'm calling my model.fit method with all these parameters. And so this is going to take you 12 minutes to run. This is going to take you 12 to 13 minutes to run. Be sure that it'll cost you around 3 hours of your TPUs. You only have 30 hours per week. So just don't be negligent in using it. Then, this bottom beneath this, the piece of code is for this competition, you have a sample submission file here, where you have to submit, for every image you have to submit the prediction. So these are some of the utility functions written to give the submissions and the image name and the predictions there. So this brings us to the end of the presentation. And so there are a few other things which I would say is, if you want to commit your notebook, that is, you can click on save version. You have two things: quick save and save run all. And you can give see if you just want to make minor changes a lot of times, you have written something and you just want to save your work, but it will get like whenever you open it, whatever you have saved you will be able to see it. But you give a run all and commit all only when you are very sure. Use this save and run all sparingly. For some reason, I would say, I'll not get into the details, but for some reason, I would say, for every small changes you make, don't go and click on save and run on. And you just can give a quick save. That should be sufficient for you, and that will quickly save your work. But if you want to you want to save and run it once, the entire notebook once. You want to save everything. You're done with all your works and done with all the editing. Then you want to save all your work. Then you can go click on. You have the other option, commit all. You can click that. That will run. You save and run your entire notebook as well. Now my notebook is not running. It's just like saving my work because I've already run it several times. So I'm just running it. But if you want to run, you can choose the other option, commit, and then you're all done with the workshop. So I'll just quickly summarize it for people who is overwhelming. I'll try to say in a simpler terms what we discussed. That's it. It's done. View.
Amazing, amazing with the workshop, Usha. That summary will definitely help.
Yeah, one this notebooks, you can go click this notebooks tab. Okay, everyone will get this tab called notebooks. Click on this notebook tab. And so when you see, you will get this DevFest top interactive session. Go and click on this top interactive session. Otherwise, your notebook will be continuously running, and that will cost you a lot of TPUs. And we've come to the, I'll summarize what we did. So we saw the problem statement was, identifying this is the image given to us. We have to classify whether a given image has melanoma or does not have melanoma. This is a skin cancer classification problem. And what we are doing is we just imported the needed libraries and all that. We saw some of the important concepts. We saw one of the important concepts was introducing TPUs. So TPUs are runtime accelerators, which means it will speed up your operation. That's it. So the reason why we are using GPUs is it's famous for its parallel execution. Whatever you can get it done in, maybe like long. I mean, whatever takes longer time in CPUs can be done very quickly in GPUs. That's why we went for GPUs. TPUs can be even more fast. They are super fast, and so that's why we go for TPUs. TPUs are runtime accelerators. And here the TPU we use is TPU V38. There's also V18. Based on whatever pricing you're choosing, you can go to Google Cloud Credits. You can go and you can purchase if you want to use TPUs for your work or your competitions in Dockship, whatever it is. Google Colab has got unlimited TPUs and GPUs, and comes with 13 GB RAM. And if that's not sufficient for your competitions in Dockship, you can also use Google Colab Pro, which you need to pay $10. I think it's worth buying. You will get priority TPUs, and you will get better RAM, and you'll also get a better version of GPUs. So the free ones you get only K80, I think. But the Google Colab Pro, I think you will get V100 GPU. So I think I would recommend highly. I just used Google Colab Pro for a month or so, and I had good experience with it. So go check that out for your competitions. And setting up the CPU TPU is very very important. So you cannot run your time is a constraint for everyone. Nobody can sit and run for weeks. You cannot sit and run your model. So this is most important thing. And the other things is like, we saw is, this is about it. To In order to use this TPU, you don't have to sit and do all the jobs manually. TensorFlow, here the entire workshop is in TensorFlow. I'm particularly using a TensorFlow 2.3 version. And so that if you're using other frameworks also has got, all these things. Other frameworks have also got a lot of methods for you to do accomplish these tasks. So I'm just talking about the TensorFlow APIs. If you're using PyTorch, or if you're running in some other different language, and R or whatever different language or different frameworks you're using, every language and framework will have its own methods. So this context, we are using TensorFlow 2.3, and which is similar to Keras in terms of syntax and all that. It's built on top of tf.kera, or what to say, Keras API. And so here TPUs are on cloud workers. So first you need to find the remote cluster. What are the remote clusters which are available at that point of time? And in that available, who's interested in connecting with you? Find that cluster, connect with the cluster. Once you connect, you should initialize it. And to accomplish this TensorFlow APIs has got some classes to accomplish this for you. You're just calling the corresponding class to do this job for you. That is identifying the cluster, connecting with the cluster, initializing it. Then the whole process of going for TPUs is for their advantage over distributed processing, right? So distributed processing, which is parallel processing. So nobody will be sitting and manually, okay, I have 100 tasks. I'm going to send first 50 tasks to this TPU, the other 50 tasks to this core. This job you will not be doing. You will be using a TensorFlow high level API. Same way, if you use PyTorch, there are several high level API. So nobody has. You don't have to memorize this API. Always have. Nobody can remember everything in their mind. Always have the practice of using documentation. You don't have to memorize all these APIs. You don't have to know anything. Take the documentation. From the documentation, you have everything neatly written for you. You can just cut copy the syntax and stuff. You don't have to memorize or don't feel overwhelmed. And there is a high level API called tf distribute which will do this job for you. All you have to do is create an object and use that object dot scope, and whatever computations, coding computations which you want to do under distributed processing, put it under that scope. That's it. This is about TPUs, and this is about setting up the environment for TPUs. And we also saw another important concept called TF record. TF record is nothing but a binary storage format which is homegrown from Google, and which is from homegrown from TensorFlow T. And if you're using TensorFlow for your end-to-end pipeline. And the reason why TensorFlow, is more preferred is you have a better productionizing environment, TensorFlow extended, which when you use the other framework, they don't have the production level environment as well coming up. So if you're using TensorFlow as your ecosystem, then you have something called TensorFlow extended. So for deploying your models, productionizing your models, you have an ecosystem ready. So a code which is built end to end in TensorFlow will fit very well and smoothly into TFX as well. So there are a lot of some of the advantages of some of the TensorFlow. So for any of the TensorFlow APIs, input pipelines specifically, if your data object is already in the form of TF records, it's going to be simpler. So it's a good practice to convert your data in any form into TF records. And this is about in this experiment, the data is already in the form of TF records for us. And we saw another pipeline called TF data. Don't try to memorize any of these utility functions. You can just cut, copy, paste these utility functions. And TF data is basically for your input processing pipeline. So all these input functions, you don't have to understand or memorize anything. You can go to the documentation. I'll just paste this documentation for you in the thing, and you can cut, copy, paste the syntax. Everything is neatly written there. TF data, we use it because this input pipeline will save us, reduce the idle time. That's why we are using this TF. If you don't use TF data, then there's going to be a lot of idle time. See, for modeling part, you are having something super fast like TPUs, GPUs and all. But before that modeling part, if you're going to use something, not going to use something which will match up to that GPUs, then you're not saving on. The reason why you go for GPUs is because you're time conscious and you want to save on your time. Then if you're going to spend a lot of time in pre-processing, that doesn't make sense, right? So you want your pre-processing also to be super fast. So TensorFlow gives you some API, which is tf.data, which is an input to create your input pipeline. And so it comes with a lot of methods and stuff. So the below part is all the utility function. And in this, I'm using an architecture for modeling, which is efficient net, but you are free to use any of the architecture which works best for you. And so use the architecture which works best for you. And then this is about the modeling part, and then the submission. So this is what we saw in the workshop today, an end-to-end flow of taking a problem and then solving it in TensorFlow and TPUs. And yeah, so I'll just share, I think I'm running low on battery. I'll just
All right.
share the
Sure.
uh, documentation link.
Yeah. I think link to your notebook, and this will definitely help people, who are going to fork your notebook, I guess.
Yeah. So
Sure.
there are a lot of questions out there. I'll take
True.
as much as if I'm just logged out all of a sudden, then it's because
True.
there's a power cut in Indranagar and
Understandable.
it's raining badly, and
Mhm.
there's no
I think,
power here.
yeah, I think people, you can stop sharing your screen. It can conserve some battery because I guess you have gone through all the notebook entirely.
Yeah,
Uh, so, okay. Now,
I'll
Usha,
just
let's begin with the questions people had.
I'll just take the questions one by one,
Okay.
and so
I'll,
after, yeah.
yeah, I'll be giving you some questions that have been asked by people. And from there, you can start answering them one by one, I guess.
Yeah, and so there is some questions in the chat bot, but you
Yes,
already have some questions,
yes,
right, with
yes,
you?
yes. I
Yeah,
have
let's
listed
go.
down all the questions, so I'm just give me a moment. Okay. So Ayush had asked a question during the workshop that how can one decide which pre-trained model to use, uh, depending on the use case?
There is no fixed strategy to use which works best. So it's all about trial and error. So you will have to try a lot of it. But what on collectively what all the competitors feel is an ensembling strategy might work.
Sure.
Might be combining multiple models together. Coming up with your own custom architecture might work.
True.
For most of the winners, like that's what has worked out. So there is no fixed strategy that this architecture is based on that. It's all trial and error. You'll have to try out multiple things, and then you have to maybe if you see a lot of winners of hackathons and stuff. They would have written a blog post after winning the competition explaining the solution. Go and check
True.
that solutions. Go and read like 10 to 15 blogs of hackathon winners. I think there's a lot of hackathons happening, and in Dockship also there's a lot of hackathons happening. I'm sure the winners will put a blog post. Go and read those blog posts, and when
True.
you read these blog posts you will find when you read the solutions of 15 people, the way they have handled it, most of them, at least 80 to 95% of them, would have come up with their own architecture or something very innovative which is not existing correctly. And so when you read it you will get an idea, and it's all trial and error. That's how it's current state. Maybe future it can change. Maybe somebody can come up with application which will tell us,
Absolutely.
for this particular use case this is the best model. Future might change, but currently this is the state. Yeah.
Okay. We have one more question. So there is a question that is fully understanding math behind machine learning algorithms a necessity for advancing in this field because it becomes a bit difficult and confusing.
Okay. So different people have different learning, strategies to follow. So personally, and one strategy which works for somebody will not work for everyone. So personally, if you take me, I'll just explain my story to you. So that might be inspiring for you. So for me, I'm an attention deficit person. So my attention is very, very limited. So if a video is more than 1 minute, 1.5 minutes, 2 minutes itself, it's very difficult for me to sustain my attention. Okay.
Okay.
And the provided if the person movies I can watch. See, I have no problems with movies, but if it's a technical video it has to be very short and crisp for me.
Mhm.
And so if you're somebody like me, and if your attention is limited, then personally this is something which might work for me, which might work for you. I don't know, you'll have to try it and see. What I would do is I would just spend few hours in getting the basic bare minimum concepts which is required.
True.
Once that little theory, maybe take one or two course which is the shortest course available, or a video tutorials. Deep Lizard is one YouTuber where she is an amazing. Freecodecamp.org has got amazing tutorials out there. Deep Lizard is a person, she's a woman, I think. I don't know which country she's from. She's an amazing YouTuber with great data science tutorials. StatQuest is another tutorial. Just take don't choose multiple courses. That is one mistake people are
True.
doing. Just take
Yeah.
one or two, one maybe, and stick to that. The best one you choose and stick to that. Learn it twice, watch it twice, so that you get the basic bare minimum concepts. Then go and start executing the competitions. So
Hmm.
once you start executing one or two competitions, Dockship has got a lot of knowledge based competitions, right? Go
True.
and execute this knowledge based competitions and all that, where a lot of people would have in the discussion forum, they would have put their solutions and all. You can just replicate, copy paste. The first time you do it, copy paste the entire thing what they did, just exactly you, so you feel confident, okay, you've accomplished something. Then takes small steps. And once you get that accomplishment, once you practice 2 3 competition, whatever minimum theory you learn, you are able to see the end to end picture of it.
True.
Then when then while you're executing the competition itself, you will come across a lot of concepts like learning rate, loss functions, and all this thing. So now you know what is loss functions in practice. Now it will be like more interesting for you to go back and learn the mathematics behind it.
Hmm.
That it will be more interesting rather than a lot of my, I'm an educator myself, so a lot of my students drop out. The reason is they spend keep aside 3 months 6 months for learning the theory, and the somewhere along the line they lose interest and drop out. So it's very important, you come up based on your, the style of learning, come up with a mechanism which works best for you.
True.
And
Okay. So we can progress further. So there is one more question. Most of the companies are looking for experienced professionals. What are your thoughts for a fresher to start a career in machine learning and deep learning? So basically, the question is that everyone is looking for an experienced machine learning person. Then how can someone with a fresher experience get a chance? Okay, I think Usha might have dropped out. She's joining. Okay, I got her message. She is joining in 2 minutes. In the meantime, uh, i- we promise that a certificate will be provided for this workshop, and we need your email and some details from you. Please fill out this form, and whoever has filled this form up will be sending you certificates your way. You can do that. So Nishchal, I guess you are also here.
Yep, should I take some questions in case?
Yes, yes. Nishchal is co-founder at Dockship, and he is also a researcher. He has done his master's from University of Edinburgh, and it is like world's top 20 universities uh, in the world. So Nishchal, there are some questions maybe you can take up while Usha is joining in. Um,
Sure. I think I can start with Shobit maybe. Do the
yes,
high level packages like Keras are slower than native TensorFlow doer model training? I think it's not that. The point is, like Usha mentioned, the pipeline actually. So when your pipeline is created, optimized for TensorFlow, it usually helps. And since TensorFlow 2.2, there is not much of a difference now, because TF like Keras has now, answering the other question in the bottom as well. Keras has now been integrated into the TensorFlow itself, because you were using two different frameworks. They have adopted the whole technology within itself. Now it's actually TF Keras. So TensorFlow, when it accesses the Keras kind of functions, it uses that. So it's
true.
usually faster now to use a TensorFlow Keras itself. So in many times of layers, like whenever we are drawing the TensorFlow models itself, we are using TF-KRS layers, not purely TensorFlow layers most of the time. So there is not much of a difference since TensorFlow 2.2 mainly, where you use a TF-KRS. So both, there is no, like the KRS is not there anymore. It's obsolete almost.
Great,
The
great.
TF-KRS that is
And
coming.
there is one more question from Ayush. So he is asking that what are your thoughts on Fast AI library? I think Usha has joined us right now. So Nishal, maybe Usha can answer this question. Can you make her the host?
No, I can't actually. Only the Prime account can do that.
Okay, just hold on a second. Usha is here.
Yep,
Okay,
I think
hi
she's
Usha.
the
I
host.
think you are here.
yeah, am I audible now?
Yes, yes, you are audible. So there
Yeah.
were some questions. So there is one more question from Ayush, and he is asking like, what are your thoughts on Fast AI library?
I think fast AI, the ecosystem is pretty good, and most of the competition winners, I would say a lot of them, we have won a lot of hackathons and competitions using fast AI. It's a pretty much good library. If you take, just like TF.data, we have a pre-processing input pipeline in TensorFlow, right? The similar to that, fast AI, you have got a lot of input pipelines and all that, which is super fast, much more preferred than TensorFlow. See, TensorFlow, the learning curve is huge. So, you have to learn so many things, and there are not many tutorials and all that. I mean, there are a lot of videos and all that, but it's not for everyone. So, for Fast AI, the ecosystem is pretty much good. Although I am a TFUG organizer, TensorFlow 2.3 version is pretty good. It's very easy to learn and all. But TensorFlow one version was horrible. Even I can't touch TensorFlow one version. It's so horrible.
Mm.
But fast AI, I think from the beginning their interface was pretty good, and
Yeah.
it's not just good. I mean, it's loved by everyone. I think you just have some 14 videos to quickly get started. You can cut down on your learning time as well. You don't have to refer any resource. Just that Jeremy has got fast AI videos out there on YouTube. It's free. You can go learn it, and he has this practical application of way of teaching. That is, he teaches with you with a problem. See, most of the courses out there, has too much of theory by the time, and a lot of Coursera courses also, which I saw, like there's too much of theory, and not more not much of relevant to the industry problem. When you're solving, it's not much of a problem relevant as well. But fast AI, I think they've put in a lot of hard work in customizing the course. The course is amazing, and it's free and available on YouTube. Now they've come up with fast book and all that. The entire ecosystem, you have
True.
amazing, in the discussion forums, you have a lot of people to help you out and all that. You can make a lot of friends as well. So it's I would highly recommend. A lot of people ask me suggestions for learning. I think you can start with fast AI as well if you have time constraints. See, sitting and learning might work out for people in the like who's like just doing engineering right now. You might have a lot of time, or who's just passed out for 2-3 years. You might, but if you are a family person who's like 40 years above, like you have kids and a lot of other priorities, time is a constraint, right? So choosing the best course is very important. Fast AI is a great ecosystem. So if you have time constraints, then just start with fast AI. Then shifting to other ecosystems will be easier once you learn that. So fast AI is a
Perfect.
great ecosystem.
Sure. And Shobit is also adding some points that they also cover all the SOTA methods such as cylindrical learning rates and have wrapped it very nicely. So yeah, Ayush, I guess it's a good library to begin with. There is one more question. How to decide when to use Adam, SDG, and other optimizers? Does it depend on dataset and the pre-trained architectures? Also, which are okay? The question is how to decide on what to use, Adam or SDG and other optimizers.
I think for most of the deep learning problems, I think it's based on the use case. So I think Adam is more frequently used optimizer in comparison for certain set of problems. There is no preset way that this is the best for this use case and all that. But if you take most of the competitions, as far I've seen, I have personally used Adam only, and so it depends on the use case. And it's mostly on the trial and error that you choose which is the best optimizer for you. But most of the image based data sets, and for the other data sets, text based problems which I have worked on, I have used optimizers. People come up with their own custom optimizers as well. So I think it's based on trial and error.
Sure. All right. I hope this answers your question, Shobit. Shobit has one more question. Does changing color space from RGB to HSV and vice versa helps in increasing accuracy?
So when you change the color spaces, you might tend to lose some of the data actually. Changing color spaces may not be a better idea, because you may lose out some of the contextual information out there. So for melanoma competition, whatever we discuss right now, I think there are few notebooks out there who have done such experiments and who has explained neatly as well. I can pass on the notebooks to shout up. And
Sure.
so changing color spaces may not be a good idea, because you might end up losing some of the contextual information. And one more thing which I would say is, in this demo, I've not used the text data. So the best model which gave the best accuracy was a model which used both text and image data, and did not change it to did not change any color spaces. So I can share you some of the I mean, there are already a lot of blogs out there in Medium, the winning solutions and all that. And there are the winning solutions for this competition. I think they've put out a YouTube video as well. So changing color spaces for this competition is not highly recommended.
All right. So as a general rule, don't change the color space. Okay. We have one question, which is like how to get selected for internship in data science. Uh, if you can throw some light.
So getting selected for internship is like your hard work, and it's very random as well. So I may not see following all these tips will not land you in internship for sure. But I cannot give you a guarantee that if you follow all these steps you will land up in internships, because I've seen a lot of people who have followed all this and still not found an internship as well. But these are some of the good to have things in your profile, which will increase your probability of finding an internship. So again, internship on which level of your career you are. There are people who are like 3-5 years experience in software engineering and then want to shift to data science looking for internships as well. There are women who have worked and taken a break because of children and other things, and then they are planning to restart their career. They are looking for internships as well. So the competition pool for internships is very high right now. And so when the competition is very high, you might should have the best possible achievements on your plate. So what are some of the achievements which is very good to have? So definitely, I think Dockship has got a lot of competitions. So instead of telling I know how to solve an end-to-end problem, if you participate in some competitions, you don't have to be a winner, but participate in some competitions, and then your the solution which you have, you can write it as a blog. And see, this is a skin cancer melanoma classification. So there are like a lot of industry use cases. I'm sure, like, what are some of the industry use cases currently, Saurabh, in the Dockship?
We are currently we have this text recognition challenge. So in that, people, it is ultimately going to be used to extract text from Aadhaar cards and driving licenses. So what happens is people upload a lot of KYC stuff these days, and that needs to be automated. So we need that kind of thing. Plus, there was this competition wherein they had to predict the demand for a supply chain. I mean, it's not an image-based problem, but it's a more or less EDA problem.
Problem.
Yeah.
Yeah. So what I would suggest is this one, which he said, converting, text from the Aadhaar card, reading this. This is pretty much a practical application. Everyone wants to use it. So
True.
you can see, you can participate in this competition. You can write your solution as a blog post, which is an indication that you know the concepts in and out. And then you can go and develop a web app. Right now for data scientists, you require a lot of good coding, and they also expect, you understand the end-to-end application framework as well. There are frameworks like TensorFlow JS and all that. So you can use one of these frameworks to develop. TensorFlow JS is used for developing, doing machine learning on web. So whatever application you develop, you can convert it into a web application. And you are developing a machine learning architecture. How is the end user using it? Is the end user going to come to the Jupyter notebook and run it? Is that how you release your application? No, right? You either release it as a web application or a mobile app, right? So whatever, you can participate in some competition in Dockship, convert that into a mobile app, release it in your GitHub. So
That's
that way you
wonderful.
will increase your GitHub thing, right? Participate in, see, there are so many competition in Dockships. So why don't you participate in some 4 to 5 competitions? Put the end-to-end code in your GitHub. See, when you put the end-to-end code, even if you copy paste from someone, you will have your own style of how you understood. You don't have to write something from original and all. See, all of us are using the pre-trained model released by Google, Facebook, and stuff. There's no originality there. We are
True.
using all the architectures, lot of utility functions released by everyone. But write the comments and such that and all that, how you understood that. Articulate it neatly in the comments. Even
True.
if you copy a notebook from somebody, give neat comments, give the credit to the original author, because not giving credit itself is a first, somebody will lose a good opinion on you, the recruiter, I think.
Yeah.
So give proper credits, and, write it in your own words, how you understood that thing. Put it in your GitHub repository, all these things. That's one good thing. Writing a blog post will add value to your profile. And
True.
then other thing is, see, you are writing a blog post. Then I recently saw this person who's Vetrivel or something. He wrote a blog post for Analytica, Analytics Vidya competition blogathon. and then he would he's publishing it as in a LinkedIn profile, Twitter and all that. See, you do great things, but then the world will get to know only if you tell that, right? If you do a lot of great things and keep it within yourself, nobody will get to know.
True.
See, not everyone likes to brag, but the way our society is there, we have to adjust ourselves to how the society functions.
Hmm.
So the way the society is currently is, the social media is serving as a great indicator for recruiters for some reason, whether it's good or bad. Instead of debating on that, to increase your visibility, social media is a great tool. So this person I saw, one XYZ, I don't want to bring his name. This person, he participated in analytics Vidya blogathon. He was a winner. He came out and he put it there. He tagged me also, but unfortunately, tagging option is disabled in my LinkedIn. But somehow it came in my feed and I just saw that post. He has tagged a lot of people and, his likes went like 200 likes. So that's a good indicator. The post went viral. And then there's a lot of recruiters. He's still doing his MTech. But there are a lot
True.
of recruiters who might see that and, who might see that post and might think, who might be also hiring and who might, be interested in hiring you. That's one thing. And second thing is for them to see, they should be a part of your connection. So
Hmm.
find out all the hiring managers out there in India and
Hmm.
add them in your LinkedIn. So, whenever you do great things and you release it in social media, it will come in their feed, right? So
Absolutely.
the recruiters,
Yeah, I can totally vouch for it. And there are a few people in our company that we have actually hired by, seeing their LinkedIn post and all. So I highly recommend this method that Usha has mentioned. Um, and yes, keep your projects out there, write blog posts, keep your GitHub updated, and that should definitely help. So Usha, final three questions, and in the interest of time, if you can, quickly skim through them. The one is that uh, are images of size, let's say 128 by 128 pixels, preferred over random image sizes, or can we use the given image size in dataset? So basically, I guess Ayush is saying that should we use a standard image size, or should we, yeah, I mean, I guess that's the
Okay.
question.
This is again, see, I can answer it in the context of melanoma, what we tried. So what we actually tried was we did 256, 524, then something in 700, it is 768 or something like that. So we tried multiple resolutions, but as you go up the higher resolution, you need that kind of a compute power to support as well. So the 256 might take a lesser time, but whereas you go for higher resolutions, the it might take more time. So you need to be well supported with the right kind of compute resources. Something like 256, 524 somewhere was giving us a better accuracy metric. So scaling up your resolutions again, it is again trial and error only. So the best solution, some of the best solutions we saw was somebody who has used a better resolution and he's trained for a lot of epochs and
Would
so
you suggest sticking to these standard resolutions like 64, 128, 256, and 512, or can we use any random resolution? Let's say,
I think random resolutions may not be preferred. I think,
mhm.
see, if you take your TPUs, the TPUs as receives inputs in a certain format only. So for a TPU pipeline and the core, the way the input is, the distributed processing is happening and all that. Whenever you use standard resolutions and all, it works better. So instead of random sizes, I haven't tried random sizes. I've only tried out the standard resolutions, but I'm not having enough clarity on, if this using the standard resolution. I assume I've read it somewhere, or I'm a little confused on this. But I think I read it somewhere in the documentation where, in the TPU documentation, that using a standard resolution is highly recommended. But I need to go and because I read a lot of things, so sometimes
True, true.
I might feel I read it, but it may not be there.
Yes.
I have to go and recheck this
Mhm.
and so I would highly recommend use a standard resolution for this melanoma competition. There's a person called Chris Diot. So he has put a discussion forum, discussion thread on this. So on various resolutions. So he was sitting and training TF records in various resolutions. If all of us have to do that, is going to cost us. He's from Nvidia. So Nvidia, I think Nvidia is the powerhouse of GPUs. So Nvidia employees, so like they'll get the best GPUs in the world. And so he has trained in all resolutions. He has created a TF record and he has outsourced it. So everyone, all of us, like we just use the ones which was outsourced by Chris Jyoti. And we never sat and we never converted it to different resolutions for this competition. And in most of the competitions, somebody does that for us. Otherwise, like sitting and doing it at different resolutions is going to cost you a lot of compute power and a lot of time as well.
That's true.
So if you want to try out these random sizes and all, it's going to cost you a lot of. I haven't tried it out, and so I cannot comment. But I would
True.
suggest stick to standard resolutions is what is preferred.
Perfect. Perfect answer, I guess. I guess there is one last question for the session. So Shobit is asking, because the CNN architectures work on feature detection, will enhancing the edge help in getting good accuracy?
Yeah, I mean, enhancing the edges of the image.
Yeah,
So these are some of the things which you do in under data augmentations as well, right? You create a lot of images with, different. You use different documentation techniques to do different transformations on your images as well. So you cannot confirm for sure, this will result in a higher accuracy. You may have to try it out. I did not try it out. So for this competition, maybe you can try it out. And these are trial and errors things. You'll have to try out a lot of things and see if it works for that particular use case or not.
true. Perfect. Perfect. So I guess there are no more questions so we have covered pretty much all the important ones. So I guess we can, conclude this presentation and workshop. And I would definitely like to thank everyone who was here, and especially Usha for taking out your, precious time today. And I understand, the weather there was not good, and your internet connection was shaky, but you still made us learn all these important concepts in machine learning. So with that, Usha, from the entire team Dockship, and I guess everyone who is here, we really thank you for your time and your knowledge that you have shared with us. And again, and for the people who are out there, again, thank you so much for coming today, guys. I hope this was very informative and useful for you too. We will be giving out the recording in a couple of days when we process it. And also, there is a feedback survey in the chat. If you can take this feedback, on the people who will be taking this feedback will be getting a certificate. So please do that. That will be really helpful for us in planning out the future sessions. So with that, I guess this is a wrap up for this workshop. Uh, really loved
Yep.
your
Can I add
presence.
something?
Yes, Nishal, please.
Yep, yeah. So thank you so much, Usha. Personally, for me as well, I've done a lot of research in computer vision, but there were some tips even I gained today. I think that will help us launch, and maybe improve some as well. So I think it was very good for someone, as you mentioned, who's done deep learning. I think it's a very good standard pipeline to use things, and try and learning from someone who has achieved something. It's personally for me as well. It's very nice, and thank you so much. And I look forward for your future sessions as well. And there are a lot
Yeah,
of
I would
concepts
love
I want to
to.
clear as well.
Yeah, I would love to contribute for this community. And, this was an intermediate level session. So if the beginners are not accommodated, we can have a different session to accommodate you as well, where we can start from the scratch. I would love to do a different session on a different occasion as well. And thank you so much to the Dockship community, Saurabh and Nishal, for organizing this workshop. And I had great time and great evening, great Friday evening well spent.
It's thank God it's Friday for data scientists, I guess. So so yeah, I mean, really loved your presence here, Usha. And yeah, that's a wrap, people.